Get an Erlenmeyer flask of a suitable size and add the mixture of your 3 organic compounds. Then, add an appropriate amount of 1.3 molarity sodium hydroxide to the mixture and swirl the Erlenmeyer around. This could also be done using a separatory funnel and a stopper, and then inverting it and opening the stopcock to release pressure. The addition of sodium hydroxide allows the acid to be extracted to the aqueous layer. Using a liquid funnel, dump your solution into the separatory funnel. Make sure there isn't a stopper on the separatory funnel, as pressure can build up and cause the stopper to fly off. Label a flask as organic layer with masking tape to keep track of where your liquids are. Then open the stopcock and allow the organic layer and the interface to drain into the labeled flask. Out of the top of the separatory funnel, dump the aqueous layer into a flask labeled conjugate base of organic acid and keep it for the recovery of the acid. Using a liquid funnel, dump the organic layer back into the separatory funnel with another addition of 1.3 molarity sodium hydroxide. Mix and vent it as previously discussed, and pour the organic layer into the labeled organic layer flask and the aqueous layer into the conjugate base flask. While cooling the flask in ice, add 6 molarity hydrochloric acid to the conjugate base of the organic acid flask until the pH turns to 1 or lower. To monitor the pH, use a glass stir rod to transfer some of the solution to a piece of pH indicator tape. Precipitate should form with the addition of acid. Heat the solution in near boiling water. Then, slowly cool to form crystals once the precipitate is fully dissolved. Use suction filtration to filter it out, then allow it to dry. Once dry, the purity can be determined through TLC and melting point analysis. Using a liquid funnel, dump your solution into the separatory funnel.
Now we will extract the basic compound 1-methylpyrrole from the organic layer with hydrochloric acid. With the stopcock closed, pour the organic layer from the previous extraction. Next, add hydrochloric acid and mix the solution in the separatory funnel. When the acid is added to the solution, the hydrochloric acid will react with the base, in this case 1-methylpyrrole. One of the hydrogens from the hydrochloric acid will be donated to the base. The conjugate acid will move from one phase, the organic, to the other, the aqueous. This is called extraction. Once this is done, you will be able to see the upper layer, which is the conjugate acid of the organic base, and the bottom layer, which is the organic layer. Drain the bottom organic layer into an Erlenmeyer flask and pour the remaining upper layer on the top of the sep funnel into another Erlenmeyer flask. Next, return the organic layer to the separatory funnel and add a second portion of hydrochloric acid. As before, you will get an interface upper and bottom layer. Drain the organic bottom layer in the Erlenmeyer flask and pour the remaining upper layer into the same Erlenmeyer flask through the top of the separatory funnel.
Next, we will have to wash our organic layer from which the 3-methoxybenzoic acid and the 1-methylpyrrole which were extracted from before. To begin, we will mix and vent the organic layer like before, however this time with distilled water. We use distilled water to extract the impurities from the organic layer while our substance of interest stays in the same phase. Next, we will mix and vent our organic layer again, but with aqueous NaCl to begin preliminary drying. The bottom layer of the organic neutral naphthalene will be drained into clean Erlenmeyer and stopped just before the interface reaches the stopcock. Now the addition of a granular drying agent is used to completely remove any water that remains in the organic layer. Once the organic layer is dry, it can be removed by Pasteur pipette through cotton and placed into a round bottom flask to remove the solvent on a rotary evaporator, leaving only neutral naphthalene.
Now we will recover the basic compound 1-methylpyrrole. To do this, we will basify the aqueous extract containing the conjugate acid from 1-methylpyrrole reaction with acid. Add a significant amount of sodium hydroxide so the pH is about 10. When the sodium hydroxide is added to the conjugate acid from the 1-methylpyrrole reaction with acid, it will lose a hydrogen atom to the hydroxide and become 1-methylpyrrole again. If the cooled basified suspension contains a filtered solid, collect it by suction filtration. Check if the basic compound is contaminated with some of the acid compound by using TLC. The crude solid may be purified by recrystallization.
Rotary evaporation is used over simple evaporation and distillation because the reduced pressure lowers the solvent's boiling point, and the rotation of the flask causes an increase in the area of surface from which evaporation occurs, which makes it much faster, and because the solvent can also be collected for reuse.
Adios, chemistry gang.